Okay, you are given a rider. A rider is a geometry problem, right? So everything is given in the information. You're given that A, B, D, and C lie on the circle. You have parallel lines, right? So CE is parallel to AB. Every time you see parallel lines, this is what it means. It means that you must think of this alternate angles, corresponding angles, and co-interior angles. Every time you're given parallel lines, these are the three things you must look for, right? And then you have E and AD produced. You have chords CB and AD. Then you're given dimensions, right? So the first question is to calculate the value of A. Okay, so like I said, you must look for these sort of angles if you have parallel lines. So if I'm going to look at this thing here, I have A. So let's look at A. A, then I have this. Then I have something like this. Then I have this. So this is what I have. This angle is going to be equal to this one here, right? Angle A is going to be equal to angle E. Alternate angles. From which side? Which sides? We have CE being parallel to AD. That is why these two angles are alternated. So E, looking at E, there's another condition too. If I'm given a triangle, look at the shape, this shape here. You have to look for these things, right? You look for conditions. Look at this here. This one. CEDF. Look at this angle here. It's an exterior angle. So it's going to be equal to this one plus this one. So angle D2 going to be equal to angle E plus angle C2. No, not C2, C1, angle C1. Exterior angle of a triangle, right? So therefore, angle E is going to be equal to 50 minus 15 degrees, which gives you 35 degrees, right? Therefore, angle A is going to be equal to 55 degrees. Okay. Looking at C2, let's look at C2, angle C2. Angle C2. We know that A is equal to 35 degrees. So now we have another condition too. Let us look at this thing here. These are the conditions you need to look for. Look at this. Look at this here. You have a bow tie. You have a bow tie. Every time you have something like this, let me show you. Every time you have something like this, every time you're given something like this, let's say A, B, C, D. Every time you have something like this, just know that angle A is equal to angle B. Angle C is equal to angle D. What's the reason? Angles in same segment. Don't forget the switch. So that's what you have. The angle C2 is going to be equal to angle A1. You see they are subtended by ED. They're subtended here, both from the circumference. It's the same arc that subtends them. So I have angle A1. Angle A, not A1, is equal to C2. C2 is equal to angle A. Angles in same segment. That's the conditions. So use our value for C2 is going to be equal to 35 degrees. So we also have 35 degrees. Now, prove with reason CF is a tangent to the circle passing through CDE. Okay. Now they want a tangent. We know that this is 35 and use a definite. This is 35 degrees. It's not visible. 5 degrees. So this is 5 degrees here. And then here we also have 35 degrees. Okay. So if they want us to prove that CF is a tangent passing through points C, D, and E, right, I'm going to the point C, D, and E. Here's C, D, and E. So it means that this shape so there's F, there's C, 1 and 2. There is D, there is E. So this is 35 degrees. This is also 35 degrees. Yeah, that's what we know. Then we know that this is 15 degrees. Good. So we have to prove that CF is equal to CF is a tangent. So how do I prove that something is a tangent? So in this case, angle C1, C2, sorry, C2. So this is C1, C2. So this is C1. This is C1. This is C2. C2 is equal to 35. Also equal to what? E, right? This is proven. Therefore, can conclude that CF is a tangent. My reason is the converse of tan chord. Tan chord. You remember tan chord? If you have something like this, KPR, right? Then it's 1, 2. With tan chord, you know that R1, right? This angle is going to be equal to this one. So angle R1 is going to be equal to angle K. What's the reason? Tan chord. So the reverse would be proving that RS is a tangent. You need to show that this angle is the same as this angle, of which we showed here. C2 is equal to E. C2 is equal to E. That is why we can conclude that CF is a tangent.